Bismillah ar-Rahman ar-Rahim. Alhamdulillah wa salatu wassalamu ala Rasulillah. In this video, we're going to continue chapter 6, the electrical systems. Today, we will learn, in the last video, we learned the basic elements of electrical systems, the resistor, the capacitor, and the inductor. In addition to the active elements, either the voltage source or the current source. Today we will learn how to model the system, how to derive the equation of motion of any electrical system. Okay, so before we go there, let's remind you of some identities and rules or laws that we're gonna use a lot. Okay, remember the Ohm's law? The Ohm's law is the relationship between the current and the resistor, and the definition of resistance. Okay, so the resistance is equal to the voltage over the current through. Okay, now if you have resistors in series, we need to learn what is the equivalent resistor or resistance. Okay, the equivalent resistance, simply the addition of all of the resistors in series. Okay, if you have two resistors in parallel, then 1 over R equivalent will be equal to 1 over R1 plus 1 over R2. Okay. All right. Just be careful. Do not get confused with the mechanical systems, the springs. Springs are opposite, okay, to the resistance. Or resistors, okay, they are opposite. Okay, just don't get confused. Okay, all right, how are we going to model electrical systems? How are we going to get the equation of motion? You look at this electrical loop. This is an electrical system. This is the equation of motion, or the mathematical model describing this system. How did we get it? We're going to use Kirchhoff voltage law. Remember Kirchhoff voltage law? We're going to use it all the time to derive the equation of motion for any electrical system. Okay, this is the short answer. Okay, so what is the Kirchhoff voltage law? The summation of all voltages inside the loop must be equal to 0, and hence we are going to get the equation of motion. Also, in some examples, some of the problems in the homework, you will need also to know what is the current law, but we're not going to use it a lot. Most of the time we will use voltage law. Current law says what? All the currents through the node equal to all the currents out of the node. As simple as that. All right, now let's focus on Kirchhoff voltage law. This is the system that we want to derive the equation of motion for. Okay, so the question is, let me use the pen. Okay, the question is, how are we going to find the equation of motion for this system? What is the equation of motion for this system? Okay, the answer is using voltage law. Okay, so you will start with your source. Okay, you will assume the current is clockwise. Okay, this way. Then you will start with your active source, which is your voltage. This is, by the way, constant. Okay, voltage like a battery. This is a number. So you will start with E plus E minus the voltage across the inductor, which is L di dt. We have to remember, by the way, Shabab, what is the voltage across the inductor, the resistor, and the capacitor. You need to memorize that. Okay. Minus the voltage across the resistor, which is Ri, minus the voltage across the capacitor, which is minus 1 over C integral I dt, equal to 0. And this is your equation of motion. Oops. Let me raise. This is your equation of motion. Okay, this is the equation of motion. Okay, remember the active element, you see it's positive because it's active element. This is the source of energy, and you can see that the voltage across any passive element will be always negative. Why? Because it's consuming energy. As simple as that. Okay. All right, let's see another example, also simple one. What's the difference between this example and the previous one? This one, multi-loop, 2 loops we have, okay? So I'm gonna assume in loop number 1, I1, and I'm gonna assume in loop number 2, I2, okay? What do you think the difference between this example and the example before? Okay, 2 loops means what? You will have 2 equations of motions, okay? So the question here, find the, he want to solve for I1 and I2, okay? And you need to derive also the equation of motion. What is the equation of motion? Okay, so you will start with loop number 1. Start with loop number 1 and say this is I1, I2. Always stick to the same model, same direction of the current. So you say here clockwise, clockwise. So starting in loop number 1, use the voltage Kirchhoff voltage law. So you will have a plus E1 minus E2. Why minus E2? Because the current here, we are assuming it's against E2, so it's going to be negative E2. Minus the voltage across R2. What is the voltage across R2? It is minus R2, I1, and there is another current on the other side, so you have to be careful. You have to subtract. Minus I2. Minus the voltage across R1. What is the voltage across R1? Minus R1, I1, equal to 0. And this is the equation of motion number 1. Okay. For loop number 2, start with your E2 plus E2 minus the voltage across R3. We have only one current here, so it's going to be minus R3 I3, sorry, I2, minus the voltage across R2, okay, minus R2 I2, minus the current from the other side, okay, don't forget the current from the other side, okay, negative I1 equal to 0, and this is equation number 2. He said also solve for I1 and I2. So how are you going to do this? This is very simple problem, by the way. Okay, this is very simple problem. Why? Because we have 2 algebraic equations. 2 algebraic equations with the functions to solve for I1 and I2. So all you have to do, the easiest way, substitute I1 in the first equation to eliminate I1, then solve for I2, then solve for I2, and substitute in the other equation, and you will get I1 to get I1, and that's it. Okay, there is another rule, very popular in linear algebra. Okay, you can use the system method. The system method we call Cramer's rule. You don't have to memorize this. You don't have to know it. Or you can use substitution method. Okay, just substitute. Substitution method is enough. Okay, substitution method. Okay, solving 2 algebraic equations. This is very simple. Okay, this is very simple. At the end, you will get I1 and I2. Very simple. I1 and I2. Okay, same way. All right. So this is very simple problem. Okay, here we learn how to derive the equation of motion. This is the most important thing in this example. All right. Now let's move to a more nice example. This is also a very simple example. Okay, what we're looking for here. He said here the input in this problem, the input is EI, this variable voltage source, and he said the output is E out. Okay. E out. Okay. So this is the input, this is the output. Okay. Okay. Find the transfer function. Transfer function. The input is what? EI, in the Laplace domain, and the output is E out. Can we do this? Yes, we can. First, you need to derive the equation of motion. What's the equation of motion, first of all? So the equation of motion, you start with EI, this is your source, minus the voltage across R1. So it's going to be R1, I1, minus the voltage across R2 minus R2 I2 equal to 0. This is the equation of motion. Oops. This is your equation of motion. Okay, we got it. I don't have to use many lines in order to avoid these errors. So this is the equation of motion. We got it. Okay, EI minus R1 I1 minus R2 I2. Okay, now next, how are you going to solve for the transfer function? The problem with this equation, okay, we don't see E out. Did he define what's E out? Yes. What did he say? He said E out is equal to the voltage across R2. So we need to define what's E out. E out equal R2. Okay, R2, R2, I1. By the way, we don't have to use the I1 and I2 because, sorry, we have only one current. I don't know why did I use this. Sorry about this. Okay, we have only one current. Okay, so we will define this as equation number 2, and this is equation number 1. Okay, we have two equations. All right. Okay, let me erase this so we don't confuse. Do not get confused with too many lines. Okay, so this is equation number 1. This is equation number 2. You know what I'm gonna do? I'm gonna open a new slide so we do it step by step together without any confusion. So let me write new slide here. Okay, go back to this slide. Okay, let me write the equation of motion first. The equation of motion is what? EI R1 EI minus R1 I minus R2 I equal to 0. This is the equation of motion. Okay, let's give it number 1. And then we need another equation defining what's E out. He said E out is the voltage across the second resistance. So we're going to call this equation number 2. Now, we need to derive the equation, the transfer function. So how are we going to derive the transfer function from chapter 4? Take the Laplace transform, assuming 0 initial conditions. So from 1, what's the Laplace transform? EI minus R1. This is not A, this is R1. Capital I. Okay, sorry about this. Let me write it again. R1 I minus R2 I equal to 0. We're going to call this equation number 3. Okay, this is from 1. And from 2, take Laplace transform. It's going to be E out equal to R2 I, equation number 4. All right. So how are we going to get the equation of the transfer function E out over EI? Okay, solve for EI from 3. From 3, what's EI? It's going to be R1 plus R2 times I, equation number not 5, it's 5, not 4. It's equation number 5. Okay, equation number 5. So all you have to do, divide E out, which is 4, divide 4 by 5 in order to get the transfer function. This will give you the transfer function E out over EI, which is equal to what? R2 I R1 plus R2 I. See? Now we will get rid of the current and we will have our transfer function which we want. So the transfer function we're looking for, E out over EI equal to R2 over R1 plus R2. Okay, R2 over R1 plus R2. Okay, so this is the transfer function that we get. Very good, very good. All right. Now, this is the block diagram. This is the block diagram representing this system. The input is EI. There is a typo here. This should be what? Not small. Should be EI. And this one, because it's in the Laplace domain, E out. Okay. Can you reduce this? What do I mean by reducing this? Can you put this in a single block? All this loop in a single block? Like this. So the input the same, EI, and the output the same, E out. So what is this transfer function? Okay. What's this transfer function? The transfer function, okay, which is going to be, by the way, E out over EI. It will be what? We will use chapter 4. It is G over 1 plus GH. What is G? G, the feed forward, everything here is G. This is G. And what is H? H, everything here. Okay, the feedback. One may say, I don't see any transfer function here. Well, it's number 1. It's number 1. This is your transfer function here, number 1. Okay, because if you multiply 1 by anything, it will be the same, so it's number 1. So this is going to be G. What is G? R2. The equivalent to the multiplication, R2 over R1, G, over 1 plus R2 over R1 times 1, which is going to be the same. Can you simplify this more? Yeah, multiply by R1. It's going to be how much? It's going to be R2. It's going to be R2 over R1. Okay, I cannot use this. Let me write it in another place. Transfer function will be how much? R1 over, if you multiply by, R2 over R1 plus R2. Which is the same as you got from here, right? It must be the same. It is the same because we are solving for the same system. You see how useful is the block diagram sometimes? Okay. So we're going to stop here at this example. Next, inshallah, we will start with this example. Inshallah. Thank you for listening.